using trig functions with coordinates and quadrants, which means that if we look at the coordinate plane, I'll explain what ASTC stands for later in the video, but I want to remind everybody that in the first quadrant, everything is positive, x and y. In the second quadrant, x is negative and y is positive. In quadrant 3, x is negative and y is negative. And in quadrant 4, x is positive and y is negative. Knowing those signs is really going to help in this section. Let me show you why. If we take a look at this first example, given the point 4, 3, find the sine, cosine, and tangent. So, what I want to do is draw a quick little coordinate plane, and then I want to graph the point 4, 3. Now, what we want to do is draw a little triangle because we want to use trig. So we started at the origin, so I'm going to draw a segment from the origin to 4, 3. And then because I know I need a right triangle, I'm going to drop a perpendicular down right from here. I know it's perpendicular because a vertical and horizontal line have to hit a right angle. And so here's my little right triangle. And based off of the last section, let's consider the reference angle. Remember, the reference angle is positive and depends on the x-axis. So if you were looking at this triangle, this would be theta, your reference angle. So if I'd like to find sine, cosine, and tangent of that angle, let's think about what we have. Here, we are going 4 units to the right, and here we're going 3 units up. So we have a 3, 4, 5 triangle, again using the Pythagorean theorem. 3 squared plus 4 squared equals x squared. 9 plus 16 equals x squared. So x squared would equal 25, and if you took the square root, you'd get 5. So let's go to our trig functions. We wanted to find the sine. Sine is opposite over hypotenuse. So based on this angle, my answer would be 3 over 5. Cosine of theta, adjacent over hypotenuse in this triangle, would be 4 over 5. And tangent of theta, using this as a reference, would be opposite 3 over adjacent 4. And so these would be our 3 ratios. Again, reminder from the first couple videos that you're plugging an angle in and you're getting a ratio out. Something else to point out at this time is the relationship between the trig functions and x and y values. So if you took a look at your picture, you might notice that the 3 would represent a y value and the 4 would represent an x value. So if I took a look at my sine function, if I'm doing opposite over hypotenuse, I was using 3 and then I was using 5, 5 being the radius. So sine, because the opposite is a y value, the sine, you could think of the sine as y over the radius. Cosine is adjacent over hypotenuse. Adjacent in this situation is the 4 or the x value. So you could think of the cosine as an x value also over the radius or the hypotenuse. The reason we're calling it the radius is if you picture this as a giant circle here, this would be considered a radius. And the tangent, if you're comparing 3 over 4, looks like it's a y value over an x value. Keeping these ideas in purple in mind might be useful later in the video. Let's keep going with this idea, given the point negative 7, 24. Okay, so if I draw a quick sketch, I know it's not going to be perfect, but if I think right negative 7 up 24, it's going to be in the second quadrant. I'm going to connect the point negative 7, 24 to the origin. I am going to drop a perpendicular here and make a little right triangle. If I'm thinking, what is my reference angle? Well, this angle right here is from the x-axis to the terminal side, so that would be theta. This direction, we went negative 7 units. This direction, we went 24 vertical units. So if I use the Pythagorean theorem, or if I remember Pythagorean triples, if I square negative 7 and square 24 and take the square root, I get that the hypotenuse is 25, which means that I can find all of my trig functions. Sine, and the reciprocal function is cosecant. cosine, and the reciprocal function is secant. Tangent of theta, and the reciprocal function is cotangent of theta. So the sine of theta would be opposite over hypotenuse. So the cosecant would be hypotenuse over opposite. Cosine of theta would be negative 7 over 25. So the reciprocal would be 25 over negative 7. Then the tangent of theta would be 24 over negative 7. And then the cotangent, negative 7 over 24. Again, it is good to point out that the 24 that's going with the sine is a y value, so the cosecant also has to go with a y value. The cosine, which is your negative 7 value, is an x, so your secant also has to do with x. Tangent and cotangent are both relating the x and the y, so if tangent is y over x, it would make sense that cotangent is x over y. Again, this will come back later to help us. So the next example, find the cosecant given that cosine equals negative 4/5 and lies in quadrant 3. Well, cosine to me is again adjacent over hypotenuse, or as we've been saying, an x value over a radius. So if I see that cosine is equal to negative 4 over 5, that means that my radius is 5 and my x value is negative 4. So if I draw a quick sketch here, and I'm in quadrant 3, that means I'm going left 4, and that also means if my radius is 5, that if I make my little triangle, this distance would be 5, and this distance would be negative 4. So we have to decide what this distance is, the vertical, so we can find our answer. Well, what squared plus negative 4 squared equals 5 squared? X squared plus 16 equals 25. Subtract that over. X squared equals 9. So I believe that this would be 3, but because we're in the third quadrant, y is negative, so that is negative 3. Why is this answer positive here? Because remember, negative squared and negative squared ends up being a positive value. So here's our little triangle. Here's where our reference angle has to be because it's based on the x-axis. So now we can find cosecant. Remember, cosecant is the reciprocal to sine. So if you want to, feel free to find sine of theta first. If you're looking at this as a reference, the sine of theta would be negative 3 over 5, which means that the cosecant of theta has to be negative 5 over 3. Given that y equals 1/4 x is the terminal side in quadrant 3, find all 6 trig functions. So let me write this as a vertical fraction. Remember, when you're looking at slope, the 1 is the rise and the 4 is the run. So this really means up 1, right 4. So if you were making a picture of what's happening in terms of your line, because your line is helping you make the triangle, if you're going up 1 and then over 1, 2, 3, 4, this is where your triangle will begin. So we're going to draw a little triangle. Let me use a different color. Draw a little triangle from the origin to up 1 over 4. Make this right triangle. Think about that this distance has to be up 1, and this distance was over 4, and this right here is my reference angle. Now that we have our picture based on the slope, we can find all 6 trig functions. So what I'd like you to do is pause the video and find all 6 trig functions, please. So please pause now. If anyone noticed that we needed to find the hypotenuse, so if you did the Pythagorean theorem and did 1 squared plus 4 squared equals x squared, you would get that the hypotenuse is square root of 17, which always causes such great joy. If you find that this is the square root of 17, the sine opposite over hypotenuse is originally 1 over root 17. Remember, you could rationalize by multiplying top and bottom by root 17 over root 17. So that would get you root 17 over 17, in case anyone tried that. The cosine would be 4 over root 17, so this as well, you could do root 17 over root 17, get this to reduce to be 4 root 17 over 17 if you rationalize. Tangent is 1 over 4. So all of these answers down here would be the reciprocals of the original blue functions before rationalizing. The next example, given this line is the terminal side in quadrant 4, find all 6 trig functions. Well, just like the last example, we want to find the slope of this line. So my goal would probably be to get y alone. So I'm going to subtract 2x. 3y equals negative 2x plus 0 technically. If I divide by 3, I'd have y equals negative 2/3 x plus 0. So if I look at my slope, if we're thinking again rise over run, you can say that the negative's on the 2. So that would mean that you're going down 2 and going to the right 3. Remember the 3 can't be negative as well, because if we had 2 negatives, you'd have a positive slope, not a negative. So in terms of a graph, we know this is quadrant 4. So if we're going down 2 and right 3 from the origin, we're going down 2 over 1, 2, 3. So this would be my radius or my hypotenuse. And if I'm thinking about what triangle would help me get a reference angle, I need to go towards the x-axis because that's the definition of reference. So right here would be my reference angle theta. And again, I can find all 6 trig functions. So what I'd like you to do before I even label my triangle is for you to pause the video, label the triangle, find the sides, then the 6 trig functions. So please pause now. Answers down here are my final answers. I found that my hypotenuse had to be the square root of 13 because this was down 2 units and this was right 3 units. Please make sure you did have a negative on the 2. I had my sine value originally being negative 2 over root 13. Here's my rationalized answer. Cosine of theta is 3 over the square root of 13. Here's my rationalized. Notice that my cosecant and sine are reciprocals. Cosine and secant are reciprocals, and tangent and cotangent are reciprocals. So please pause if you want to check your answers. And we're going to keep going to the next example. Start asking ourselves are these questions. Where are sine and cosecant positive? Let's think about that. Sine, I've been saying, is really the relation of y over r. So what you want to ask yourself is where is the y value positive in these 4 quadrants? If you're thinking quadrants 1 and 2, I agree with you. So where is sine and cosecant positive? Quadrants 1 and 2. If I ask you where is cosine and its reciprocal secant positive, remember that cosine out of the past couple of examples has really been x over r. So if we look at our coordinate plane and say where is x positive, well, x is going to be positive in the first and fourth quadrants. So same with cosine, quadrants 1 and 4. And finally, tangent is a sneaky one because tangent is really defined, as we've seen, as y over x. So that means either both of these numbers have to be positive, like in quadrant 1, positive divided by positive is positive, or in quadrant 3, because if you had a negative y over negative x, these would change to a positive. So quadrants 1 and 3 are the places where tangent would be positive. So guys, what I'd like you to do for this last example is pause the video here and please copy down all the information that I've written down so far, and I'll be right back with you. What you're really asking yourself is where is sine or y negative and where is x or cosine positive? Well, the quadrant where x is positive but y is negative is quadrant 4. The last example, where is cosine or x positive? So I'm between quadrants 1 and 4. And where is tangent negative? Well, we learned last time that tangent is positive in the first and third quadrant, which means it has to be negative in the second and fourth, which means yet again, quadrant 4 is our answer.